Today's lesson will cover the distributive property. Let's see how the distributive property works. Here I have a diagram that you're going to want to copy into your notebook. It says a gardener has divided a plot of land into two sections. The smaller section is used for growing vegetables. So this is where the veggies are. And the larger portion is for growing flowers. Go ahead and pause me while you get that diagram copied into your notebook. When you're ready to come back, hit play. All right, so in your journal or your notebook, I want you to do a couple of things. First, how would you find the area of the whole garden? I want you to show your calculations. Then explain what you did. You don't necessarily need complete sentences, maybe just bullets, step 1, step 2, step 3. Then, could you check your work by finding the area of the garden in a different way? Think about it. There's probably another way to find the area of the garden. If you do your calculations that second way and you get the same answer, then obviously you are correct. And then explain how you checked your work. You're going to have to pause me while you do all of that journaling and come back when you are ready. So if I was working this problem, I might think about it as the area of the veggie side plus the area of the flower side. So if I did that, the veggie side is a 10 by 12 and 3/10 rectangle, and the flower side is a 10 by 12 and 7/10 rectangle, which gives me 123 square meters for veggies and 127 square meters for flowers, or a total area of 250 square meters. That might be one way to do it. Or I might think of this as one big rectangle. That one big rectangle is 10 by, and then I would have to add how long the veggie side is plus how long the flower side is. Well, that long side is actually 25 together, so I still get 250 square meters for the area of my garden. So in my first example, I thought about it as two smaller parts that I added together. And for the other way I did it, I thought of it as one big rectangle. All right, so here's a similar problem. It says a local swimming pool ropes off the deep end for safety reasons. The entire rectangular pool measures 20 feet by 50 feet. The rope crosses at the 30-foot mark. First, I want you to draw a model of the pool. Then, I want you to show two ways to find the total area of the pool. And so you're going to have to pause me while you do this work and then come back when you're ready. So here I have a diagram of our pool, and I can find two ways of showing the area. I can think about the bigger end is a 20 by 30 rectangle, and the smaller end is a 20 by 20 rectangle, which gives me 600 square feet on the bigger side, 400 square feet on the smaller side, or a total of 1,000 square feet. That's if I thought about it as two separate parts. Or I could think about it as one big swimming pool, which is a 20 by, the long side's 30, the short side's 20, which is a 20 by 50 pool, which would also give me 1,000 square feet. So again, I got the same answer whether I thought about it as two smaller rectangles or one large rectangle. So here we have our official distributive property. If you look at this, here I have something that looks like an entire garden or an entire swimming pool. And that equals one of the smaller rectangles plus the other smaller rectangle. The same thing happens if I were to subtract. Now, mathematically, it is called the distributive property because I am taking A times B and I'm taking A times C. On my second example, I am taking A times B minus A times C. I'm distributing my outside factor onto both things inside the parentheses. So to be fluent with the distributive property, it's going to be important that you're able to convert between the two forms, the expanded form and the condensed form. So let's start with the expanded form. For example, we might have 8a plus 8b, and we want to put that into a format where we have a single number and then one set of parentheses. So what you're searching for is what is being repeatedly multiplied. You're going to pull that out. That is going to become your factor on the outside of the parentheses. And then what you have left, the A and the B, they are going to live inside the parentheses, paying attention to if you're adding or subtracting. So we can do the same thing when we are subtracting. For example, we might have 17c minus 17f. And we're looking for the factor that's being repeatedly multiplied. And then we're going to have a set of parentheses. So it looks like 17 is in common, so I'm going to pull that to the outside. That leaves a C and an F in the center. And I'm going to pay attention to if I'm adding or subtracting. I am subtracting, and I'm done. So let's try going the other way. Let's say we have the condensed form, and we want that to be expanded. So we might have something like 5 times, 3 plus z. In this case, I'm going to end up with 2 sets of parentheses because I have to make sure that that 5 gets distributed. So in the first set of parentheses, I'm going to have 5 times 3. In the second set of parentheses, I'm going to have 5 times 2. I'm sorry, that's not a 2. Let me erase that. Z. Sometimes my 2's and my z's look alike. And I was adding, so I will add. I can simplify this then into 15 plus 5 z's. All right, let's try again, this time with subtraction. We might have 10 on the outside, and we might have m minus 20. In order to expand this out, I need 2 sets of parentheses. I'm going to take this 10, multiply it onto the m for my first set of parentheses. I'm going to take this 10 and distribute or multiply it onto the 20 for my second set of parentheses. I was subtracting, so I will subtract my parenthesis sets. 10 times n would give me 10 m's. 10 times 20 would give me 200. And I am subtracting. That is my answer. So here's one I would like you to try in your notebook. It says a community center offers a canoeing day trip. The canoeing fee is $80 per person. The cost of food is an additional $39 per person. Find the total cost for a family of 4. I want you to write 2 equivalent expressions for this problem and solve it. So while you are working, pause me, and when you've got your answers, come back for checking. So here's how I would approach this problem. So I know we have to pay $80 for the canoe fee and $39 for food, and we need to take that whole thing times 4 people. Or I could think about it as just the canoe fee. I need 4 canoe fees, and I need 4 food fees. Notice it is the exact same thing because I distributed the 4 onto the 80 and the 4 onto the 39. So either way you do it, you will get $320 for the canoe trip, and then you will get another $156 for food, for a grand total of $476. So the distributive property is super important that you learn if you're going to be successful in algebra at any level. But I find that I use it more often in real life when I'm trying to figure out mental math. So let's see if we can use the distributive property to help us with some mental math problems. So this first one, 8 times 36. If I was thinking this through, I would probably think about it using the distributive property. I can change this 36, I'm going to put a little thinking bubble, into a 30 and a 6, both of which I'm going to multiply by 8. So if I did this the expanded form, I could take the 8 times the 30 and the 8 times the 6. So in my head, I can do this. This is 240. And I can do this as well. That's 48. And I can do this in my head. That's 288. So if you decompose 36 into a 30 and a 6 and apply the distributive property, you should be able to get these products using just your head, no pen, no pencil, no calculator. So let's think about this one. I want you to pause me while you're thinking about what that answer could be, and then come back when you're ready for me to see what my thinking is. So I would say there's no one right way of seeing this problem. I could see it as a 6 times 20 plus 9, but I could certainly also see it as a 6 times 30 minus 1. Let's try this both ways. You know what? I'm going to take that back. I can see it also as a 6 times 25 plus 4. Let's try it these ways and see if we get the same answer. So if I take 6 times 20 and 6 times 9, I would get 120 and 54, and that's 174. Let me try it this way. If I took 6 times 30 minus 6 times 1, I'd get 180 minus 6. My goodness, 174. Okay, let's try it the last way. 6 times 25 plus 6 times 4. Well, if I'm counting by quarters, that's 150. That's 24. And I get 174. There are multiple ways of doing these problems. One way isn't better than any other. It has to do with what facts you can do mentally in your head that are easy for you to deal with. Pick one, go for it. All right, your job is to try these two. I want you to think them through. No pencil, no paper, no calculator. Until you have your answer, then I just want you to jot down what you think the number is for the answer for the first one and what number you think the answer is for the second one, and then you are going to come back to me and check. So go ahead and pause while you're working. All right. I might think of this one as 5 times a 30 and an 8. Somebody else might think of it as 5 times 40 minus 2. Somebody else might think about it a different way. Doesn't matter which facts you choose as long as you get the right answer. So on this first one, if I thought about it as a 5 times 30 and a 5 times 8, I would have had 150 and 40 more for 190. If I thought about it like this, I would have had 5 times 40 minus 5 times 2. So this would have given me 200 minus 10. As I said, same answer. One isn't better than the other. It's just what you're comfortable with. This last one, I might think of this as a 9 times 40 plus 9. Or I might think of it as a 9 times 50 minus 1. Let's try both of those and see what happens. 9 times 40 and 9 times 9. Now this might not be one I choose to do. This one's a little hard for me to think about in my head. It's not terrifically difficult. This is 360 plus 81. But I do have to do a little bit of thinking. I think that's 441. For me, it's easier to do this one. 9 times 50 minus 9 times 1, which would give me 450 minus 9 is 441. Same answer. Doesn't matter which way you do it. Pick some factors that are easy for you to work with in your head that also work with the problem and go for it. All right, we are at the end of our distributive property lesson.